students, welcome back to the mathematics class once again. In today's class, I am going to discuss with you lines and a transversal. In that concept, before going into the concept of lines and transversal, I would like to do two more problems which I have left over in exercise 4.2. in the previous video lesson. Okay, the previous video lesson, you can click on the I button and get it notified. In that exercise 4.2, we have done so many problems and last two problems are left over. We will complete those two problems and we will shift over to the concept of lines and transversal. Now let's get started. I have noted down the problem, that is the seventh one. In the given figure, see the figure here, PQ is a line, ray OR, see this is perpendicular to the line PQ. This ray OR is perpendicular to the line. That's why it is written here, the box angle, that is 90 degrees. And OS is another ray lying between rays OP and OR. See, OS is another ray lying between OP and OR rays. Okay, that information is given and we have to prove that angle ROS is equal to half of angle QOS minus angle POS. Okay, this we need to prove. Let's get started here. With the known information, we have to find this angle. Okay, here in the given PQ is a line, this is a line, and OR is a perpendicular given. So since OR here, OR is perpendicular to PQ line, yes, OR, the ray OR here given is perpendicular to the line PQ. This is given, isn't it? If it is perpendicular, these two are 90 degrees, isn't it? Here, and QS is another ray lying between these two. These two rays, OR rays and OP rays, OS is another ray lying between them. From this information we have here, let us take this angle ROS. Okay, let us take angle ROS equals to, this angle is equal to, since this is perpendicular to this complete angle is 90 degrees. So this ROP or POR is 90 degrees. So 90 degrees minus angle POS, I can write, see, POS. So this 90 degrees minus POS, if you remove, we get ROS angle. Okay, so let us suppose this equation 1 we will suppose. Okay, now let us take this part, this is 90 degrees and this here ROS. Again let us take here this angle QOS, right? From there, I can also write angle ROS is equal to, this angle ROS is equal to, here angle QOS subtracted from angle QOR. Okay, angle QOS, this angle subtracted, this angle QOS minus 90 degrees. We can take this as 90 degrees because this is a perpendicular given. OR is perpendicular to this. So what I have supposed, first I have taken ROS, this side, to this side ROS, this is nothing but 90 degrees minus angle POS. That is equation 1. Now to this side if you see, ROS is equal to angle QOS subtracted angle QOR, which is nothing but 90 degrees QOR. So that is the second equation. So from 1 and 2 if you see, angle ROS and angle ROS, let us what we'll do, add both the equations, adding both equations 1 and 2. Let us add. So that means adding means LHS side adding and the RHS side adding. Here if you add both of them, you get 2 angle ROS. And here if you add 90 minus POS, this, let us add 90 minus angle POS plus angle QOS minus 90 degrees. So the LHS part I am adding, this LHS part and RHS part I am adding both sides. Here 90 and 90 gets cancelled off because minus and plus. We got angle ROS. If you write the positive one this side, here angle QOS minus angle POS. Now here we need to prove this. Half should be there. So 2 we will shift it to the other side of the equation. So that becomes half of angle QOS minus angle POS. This is what we need to prove. Hence proved. Please note it down. Yes. The 8th problem, it is given that angle XYZ equals to 64 degrees. XY is produced to point P. A ray YQ bisects angle ZYP. Draw a figure from the given information. Find angle XYQ and the reflex angle QY and P. Here asked, first we have to draw a figure from this given information. Then later on we have to find both the measures of these angles. Okay, let's proceed by drawing the figure for the above information. Now if you see, here given angle XYZ is equal to 64 degrees. So let us draw that. So that means, let me draw here. So let this be X, yes, here X, Y, Z. So this is Y and this is Z. Okay. So let me write it as Y here. Okay. And this is given as 64 degrees, right? And XY is produced to point P. A ray YQ bisects ZYP. So XY is line, this line, it is produced and it is extended to a point P. So let me extend this. So let this be a point P. Yes. And a ray YQ bisects ZYP. So the angle Z, Y and P. So this is the complete angle. In this angle, this ray YQ bisects. Here bisects means making into equal angles, equal parts. So that means this angle is bisected. So like this. Yes. This is YQ. Yes, YQ. YQ ray bisects. So bisecting means these two angles are equal. It is making equal angles. So it is bisecting this ZYP into two equal angles. Intersect means we can just intersect, but here bisect means it is making two equal angles. So this is the information given. Draw a figure from the given information. This is the first part of the question, and find angle XYQ. See here, X, Y and Q. This complete angle, the 64 degrees and this angle we have to find, and we have to find the reflex angle QYP. Here QYP, this angle, but we need to find the reflex angle, right? So how do we proceed? We don't know these two angles. How much is these two angles? We don't know. Let us suppose, let angle ZYQ equal to X degrees, that is equal to QYP. Okay, angle QYP, because both these two are making equal angles. Since YQ ray bisects what? Angle ZYP. So this ray is bisecting, so these two are equal angles. So let me suppose this as X degrees, so this also will become X degrees. Now if you see, angle X, the line XY has been produced to the point P. That means this line is been extended to this point. That means this complete Y, this X and P is a straight line. So the angle on a straight line is 180 degrees. So since XP line, so since XY, we can write as XY line is produced to P. Here angle on XY angle on xy is 180 degrees, because angle on a straight line is 180 degrees, isn't it? This complete angle is 180 degrees. So these two angles plus this angle complete must be equal to 180. So likewise we can find, therefore 64 degrees plus x is equal to 180. You got? That means 2x is equal to this. If you shift over to the other side, 180 minus 64. So 2x degrees is equal to, if you subtract it, this becomes 116. Okay, 116 degrees. So x degrees is equal to, if you divide it, it becomes 58 degrees. So each angle is, we got it as 58 degrees, and this is 58 degrees. We got that. So here asked, find x, y, q. So that is x, y and q. But we got this 58. So this is 64. If you add both of them, we can get x, y, q. Therefore, angle x, y, q equals to 64 degrees plus 58 degrees. Right. That comes to 122. 122 degrees is x, y, q. Yes. And we have to find the reflex of QYP. First we will find QYP. The reflex angle means this angle. Okay. So you can also do, this angle is x, QYP is 58 degrees. The reflex angle will be 360 minus 58 degrees simply. Okay. So reflex angle QYP equal to this part, this complete part. So this angle QYP is 58 we got. So 360 minus 58. That comes to just 302 degrees. So these are the two informations we got it. Please pause the video and note it down. See here, before proceeding into the concept, I told you two problems which were left over in exercise 4.2. To do the exercise 4.3, we need to learn this concept of lines and parallel and the transversal. Okay. See, I have drawn two lines here, line M and N. If they form a pair of lines, isn't it? A pair of, here if they are parallel lines. If there is a pair of parallel lines, and if I draw another line which meets these two lines, I am drawing another line here. See here, line L. I'll suppose this as line L. This is meeting these two points at distinct points. These two lines at distinct points. So let me suppose this as P and this point as Q. Okay. So such line which meets a pair of parallel lines or a pair of lines at two distinct points, such line is called as a transversal. Okay. So here transversal is a line L. Okay. So here if there is a pair of lines M and N, and there is another line which meets these two lines at two distinct points, so such a line is called as a transversal. Now this transversal is making how many angles here altogether? We have 1, 2, 3, 4, 5, 6, 7, 8. So it is making angles 8 altogether. So let me suppose this as angle 1, this is angle 2, this is angle 3, and this is angle 4 here. Now the same thing here, 5, 6, angle 7 and angle 8. So the angles formed are totally 8 angles, right? So how many angles? 8 angles are formed when a transversal meets a pair of lines at two distinct points. Here preferably M and N, here I have drawn parallel lines. Okay, see here. Now what there are specific names for all these angles formed, and there are the theorems proving some concepts here. Okay, let us discuss about those. Now if you see all these pair of angles, all these angles, 8 angles, one angle, see here, if you are seeing angle 1, yes, and angle 5, okay, angle 1 and angle 5, and another pair I'll write angle 2 and angle 6. Here angle 2 and angle 6, and another pair that is angle 4 and 8, angle 4 and angle 8. And if you see angle 3 and angle 7, angle 3 and angle 7. So here there is a specific pattern here. First case I have taken the outer angle and the inside one, and here this inside one and outside one. Here outer, inside and outer. So these form, I'm telling these two, these are a pair. These are 4 pairs, okay? 4 pairs here. These 4 pairs of angles are called as corresponding angles. 4 pairs corresponding angles. Okay. Just by seeing the all 8 angles, we can also say here these two, 1 angle, 2 angle, 7 angle, 8 angle. These 4 are exterior angles which are outside. Inside angles, see here interior angles, 3, 4, 5, 6. Likewise, we can also say. But here these 4 pair of angles are called as corresponding angles. How to remember the corresponding angles? One angle is exterior, one angle is inside, and to one side only they are, to one side of the transversal only they are. Again, if you are taking interior, the other one is exterior. Likewise. So these 4 form a pair, 4 pairs of corresponding angles. Now let us see others. Okay. See, we know that 3, 4, 5 and 6 are all interior angles, and if I take angle 3 and angle 5, see here angle 3 and angle 5, this is one pair like this, and this is one pair. I'll take these two, angle 4 and angle 6. So these two form 2 pairs, okay, 2 pairs of interior, because they are interior inside, isn't it? Interior alternate angles. They are called as interior alternate angles. Yes. So 3 and 4 and 3 and 5, 4 and 6. They are inside as well as they are alternate to the to the other side and to this side. So they are alternate angles. So 2 pairs of interior alternate angles are there. Now another pair, let us define here. So if you see this, only 3 and 6, these are also interior angles, but to one side of the transversal. So this L is transversal. If you are taking 4 and 5, these are also interior angles, and to one side of the transversal, to the other side. Okay. So we will take that 3, angle 3 and angle 6 here, and angle 4 and angle 5. These are 2 pairs of interior angles on same side of transversal. Okay, see here, to one side 3 and 6, to this side 4 and 5, that I wrote. So we have altogether here, this is one type, that is corresponding angles. So how many corresponding angles? 4 pairs. And we are taking this type, this is interior alternate angles. They are 2 pairs. And here we are taking 2 pairs of interior angles. They are not alternate, remember, interior angles, but on the same side of the transversal. So these are the, and also we can write, if you are writing the interior angles, we can also write the exterior angles also. So 2 and 7 are the exterior angles on same side of the transversal. 1 and 8 are the exterior angles on the same side of the transversal. Okay, so according to this, we have that these always, the corresponding angles are always equal. That means angle 1 is equal to angle 5. Okay, so corresponding angles are equal. Okay, and the axiom also says that 2 pairs of alternate angles are equal. So if one angle is given, the other angle we can find, because they are interior alternate angles. This is an axiom. Okay. And here two pairs of interior angles on the same side of the transversal, they are not equal, but their sum is equal to the sum here. Their sum is equal to 180 degrees. Okay. So that means 180 degrees, I can write two pairs of interior same side of the transversal. Okay. Interior angle sum. So angle 3 plus angle 6 equals to 180. That means their sum is supplementary. So 180 is supplementary. Complementary is 90 degrees. So 3 and 6 form supplementary angles. 4 and 5. This 4 and 5 form supplementary angles. If you know one angle, we can get the other angle by subtracting it from 180 degrees. So these three are the axioms when a transversal meets a pair of parallel lines at two distinct points making 8 angles. Okay, the angles we knew and their axioms. These are the types of angles, and the axioms involved is that corresponding angles are always equal. That means angle 1 is equal to angle 5. Angle 2 is equal to angle 6. Angle 4 equal to angle 8. Angle 3 equal to angle 7 according to the axiom. And the same thing, two pairs of interior alternate angles are equal. That means angle 3 equal to angle 5. Angle 4 equal to angle 6. Whereas when we see this, two pairs of interior angles on one side, that means on the same side of the transversal, are always supplementary. So that means their sum is equal to 180 degrees. So this is about the transversal and the angles here. Now let us do one solved problem. Now I have noted three figures here on the board. Here, if you see these three, second one and the third one, all these are parallel lines, pair of parallel lines intersecting with a transversal. Here, if you see the first one, P and Q are parallel lines. Here, P is parallel to Q line, and given that R is a transversal. Okay, we need to find the measure of X. Yes, the similar way here, L is parallel to M and Q is transversal. We have to find the measure of X. Here X. So let me take this as Y. So this as Y. And here if you see, L is parallel to M and N is transversal. Okay, see here, let's start the first one. Here we have to find the measure. We know that a pair of parallel lines is being cut with a transversal. We get corresponding angles, isn't it? So the corresponding angles are always equal when the pair of angles are parallel to each other. So here we can clearly say x degrees is equal to 84 degrees since corresponding angles are equal. So from this axiom are equal. From this axiom we can say that x degrees is 84 degrees. Right. From here we can say, this is alternate angles, sorry. Here these two are alternate, isn't it? Alternate angles. Interior alternate angles in specific you can call. Interior alternate angles. Okay, sorry. Corresponding means one exterior and one interior should be there. Okay. These are interior alternate angles are equal. The second axiom. So likewise. Now the second problem here, if you see, this is 53 and Y. These two are corresponding angles when L and M are parallel and Q is a transversal. So Y is equal to 53 degrees since corresponding angles are equal. Angles are equal. And here when you come to the third figure here, L and M are parallel and N is a transversal. Now if you see these two angles, they are on one side of the transversal. So the angles on the same side of the transversal are supplementary. So that means Z plus 100 degrees is equal to 180. So Z equals to 80 degrees. So one side of the transverse. Likewise, we can find out the angles if one angle is given. Let's see the other problems of exercise 4.3 in our next class. Thank you all.